Hi guys, this is the last video on section 3B. We're going to do a few more inequality problems, graphing them, solving them, and graphing them. We're going back to the AND condition. We've kind of been flipping back and forth between OR and we're going to go back and work a few more AND problems. Let's see if I can get a thinner pen. Okay, so basically remember when you have an AND condition, they must overlap. The solution that you're going to finally come up with must be in both, satisfy both of the inequalities. And as we graph them, that's what we're going to consider as we go along. So our first one, if we look at our first one, x is less than 3 and x is greater than 0. Our target points are 0 and 3, so I'll go ahead and I'll write them. And neither one of these have the solid line underneath it, so we know that our circles are going to be open. The first one, x is less than 3, looks like that. Straightforward. X is greater than 0, looks like that. And that's what they look like if they are graphed individually, but when we put them back together, we need all of the points that satisfy both of those conditions. So here's 0 and here's 3, and the only points that satisfy both of the conditions is the segment of the number line that's in between the two. Doesn't get to 3, doesn't get to 0, but it's this line segment right here. And when we write this, as a more educated looking math person, we can write it as a single inequality, and you usually put the smallest number over here, so 0, and the x goes here, and the 3 goes there. And this says our solution set is greater than 0, x is greater than 0, but also less than 3. And notice this thing right here, it's customary to write using the inequalities pointing to the left. It doesn't make it wrong, but it's just something that is a math convention that you guys will want to get used to because this is the way you're going to see it. So let's do these two at the bottom. So we have these inequalities. There's two different ways to work these, and I will work them both ways. I'll work A one way and B the other. These are two separate inequalities, so you can split them up. -7 less than or equal to 3x minus 1. And on the other one, you have 3x minus 1 less than 11. And you can work these individually just like you would any other problem. I'm isolating my variables, so I'm going to add 1 to both sides. I'm going to end up with this, and that would be what? -6. At this point, I prefer to have my variables on the left, so I'm just going to pick 3x and put him over here and put 6 over there, but remember I have to flip the sign. So now I'm going to divide both sides by 3, and I get x greater than or equal to -2. That's this side. Coming on down on this dude, I'm going to add 1 to both sides, 3x less than 12. My variable's on the left-hand side. That's perfect. I'm going to divide by 3. I'm not flipping the sign because I'm not dividing by a negative number. And I get x less than 4. So my compound statement is going to say, I want to graph and show all the points that are greater than or equal to -2, but they also have to be less than 4. So when I write the statement in a more mathematically correct way, I am going to say, I'm going to put my x in the middle. Remember, our inequality symbols are going to point to the left. So x is going to be less than 4. He comes down on that piece right there. And over here, we're going to say x is also greater than or equal to -2. So actually, I moved my guy around. Maybe it would make sense to you if you left him on the other side of the inequality symbol. But at any rate, this is our answer, and now we just need to graph it. So here's our number line. Here are our two target numbers, -2 and +4. We want all the numbers basically in between the two, but it can include -2 because of the line underneath it. 4 is an open circle. Should have done this in another color, but you guys are picking it up. So there's my graph. Here's my answer written mathematically. Here's my answer graphically. Okay, the second way to do these is not to split them up, to just handle all of the getting the variable by itself in the form that it's in. So this is what this looks like. And this is probably what you guys will like, I would assume. So to get the, I'm still trying to get this x alone. He's got a bunch of stuff attached. I'm going to subtract 2 from all 3 places. This is legal. And I end up with 0 less than negative 5x less than 10. So we're almost there, but we need to get rid of the coefficient negative 5. So we're going to divide all 3 terms by negative 5. Of course, when we're dividing by a negative number, our arrows, our inequality symbols flip. So we end up with positive x greater than negative 2 on this side, and on this side, anything with the numerator of 0 is 0. So now you notice we've got our compound and situation already written in its final form. And we're basically saying that that x is less than 0, greater than negative 2. Now, the only problem with this, and maybe y'all see this, but the only problem with this is that it's really not written with the inequality symbols pointing to the left. And it also has our smallest value over here on the right-hand side of a 0. So this kind of doesn't mathematically look quite right. So what we want to do is flip the negative 2 over here, put the 0 over here, and switch our inequality symbols. So now we have our inequality symbols pointing to the left. We have something that's more easy to understand how to graph it, at least in my mind. You want all the numbers that are greater than negative 2, but they have to be less than 0. So both of our target points are open, and we just want the guy in between. So oftentimes, most oftentimes, when you are graphing an and situation, notice the word and is not in either the A or B problem. You have to notice that it is a compound inequality written like this. When you have an or condition, you will always see the word or in the original problem. So when you have an and condition, generally speaking, your final graph is going to be a part of a number line. It's not going to be going in opposite directions forevermore. So this is the end of this video. We'll talk about it. We'll do more in class. Of course, you have your video check, and we'll come back together and see what questions you have for me. Thanks for watching.